All right, so just some tips, just to get you kind of going, get your mind focused in the right direction. If I were you, if you're not sure about this, I would follow along and write these tips along with me. All right, so this is like our jump start, power to a power. And what you have to remember here is to give yourself the exponent and then to distribute the power to a power. Okay, and same thing here. You got to give yourself an exponent and then distribute the power to a power. And then remember on number 2, you have to deal with your negative exponent. Okay, deal with your negative exponent. All right, numbers 3 and 4, I don't think I need to review, just simply takes looking at it and deciding whether it is linear or nonlinear. Okay, linear or nonlinear, that's all it's asking you there. Whoops, there we go. Linear or nonlinear. And remember, on the ones that are in a table, you need to show this work of showing whether or not it is a constant rate of change or not. Okay. Number 5 tripped a few people up the other day when we were walking the room. It wants you to decide if it is linear, right? Which one of these is linear? Well, we can right off the bat knock out some that are not linear. So it brought it down to A and B. Well, A has some parentheses. Deal with the parentheses first by distributing 5A times A and then times 3. And when you do that, you will get A equals, and then 5A times A is 5A squared plus 3. And that should help you decide between A and B as far as which one is linear. So if you see parentheses, distribute first before you decide whether or not it's linear or not. Okay. All right. On the bottom, 9A and 9-9, there's really no shortcut for these. Okay. These were the ones that were a little time consuming. Yes.
On what you have those, you still write this stuff down, as tips.
If you need the tips, then I would write them down. If you don't feel like you need them, then don't. For 9-8 and 9-9, there's no shortcut or anything like that. Anytime you're graphing, and here it does tell you that you are graphing each function, you need to do your table, okay, with your x, and you're evaluating y equals negative x cubed. And I do want to talk about this one a little bit because this one was a little unique in that there was a negative out front. So I wanted to talk about that. All right, so I'm going to kind of blow this up for a minute. We know that if it is a cubic or a quadratic, what numbers do we use? Anybody remember? -2, -1, 0, 1, and 2. Okay. Now, what I want to point out here is this negative is really saying -1 times x cubed. So when you're doing PEMDAS, make sure that you do y equals -1 times -2 cubed. And now, when you're doing PEMDAS, you do the exponent before you do the multiplying of that negative or that -1. Okay, so that means the -1 stays. Then we take -2 to the third power. -2 to the third power is -8 because it's -2 times -2 times -2. And then -1, now we distribute that negative and we get -1 times -8 is +8. So the point is -2, 8. All right, so I wanted to just do that first line so that then you could then do the rest. But remembering that when you have a negative right here, when you have this negative behind an X like that, you have to remember, and if it helps you, and it always did me, if it helps you, rewrite it, -1 times x cubed. And that way you remember that that negative out front gets applied after you do your power. Okay, that right there is a big help on this one. All right, for number 2, where's the x? The x is in the exponent, so that means it's an exponential equation. And when it's an exponential equation for our x's, that's where we use 0, 1, 2, 3. Okay. And that's all the help I'll give you there. You apply the exponent, then you do the subtraction. Always follow PEMDAS on all of these down here. Always follow PEMDAS. Okay, making sure you do those exponents before you do any multiplication or addition. On the bottom, it's 2 quadratics. Okay, so that means you're going to have 2 separate tables. You're going to have a table for this one, and you're going to have a table for this one. Okay, so you're going to have 2 separate tables. You're going to graph them both on the same graph, and then notice in the instructions, it says describe their similarities and differences. That means use your words. Okay, how are the graphs the same? Do they open up the same? Are they both pointing up? Are they one pointing up, one pointing down? Is one wider than the other? Are both of their origins at the same spot or not? Well, that center point, okay? Trying not to use terminology we use in algebra, but the vertex or that middle point where it turns and takes a sharp turn and goes the other way, are the vertexes the same? Is one wider than the other? Do they both open up? Does one open up, one open down? That sort of thing. So you need to first do 2 tables. Then you need to graph them both. Then you need to describe their differences and similarities, okay? All right, on the second page, the one I just gave you today, this is a brief review, and you'll notice if you want to really quickly, I whited out some of these so that you wouldn't have so many to do. So if you'll notice number 3 is missing, you won't have a number 3 answer. Number 8 is missing, you won't have a number 8 answer. And then I took out 12 and 13, but I also took out the lines for 12 and 13. So you won't have a number 3 and a number 8. I forgot to white out the answer lines when I whited out the problem. These are all relatively quick. So just as a review, number 1, just want you to write it using exponents. So keep your base, write your exponent. For number 2, they want you to evaluate it with A as a 2. So in the A spot, so that would look like 7 times 2 to the 3rd power. And as long as you remember PEMDAS, you'll be fine. Okay. For number 4, I definitely want to set this up and remind you guys when it wants the prime factors, and that's what it's asking for here. It's asking the prime factorization. That means you're going to take 42 and you're going to do that factor tree, and you're always start with a prime number on the left. So you're going to start, since it's even, I'd start with a 2 and then keep going from there. And then over here on the answer side, you're going to list all your prime factors. You're going to list all your prime factors, but you're also going to break out A to the 3rd as A times A times A and then times X. So break out your numbers and your variables as prime factors, meaning that the exponents are all going to be 1 and they're all going to be prime numbers and variables. Okay. All right. This is an example of what kind of the pre-example I showed you on the jump start. When you're multiplying exponents, when you're multiplying like bases, right? Your base stays your base, and then you add your exponents. Okay. So when you're just multiplying like bases, you add. Here, it's just another way of writing multiplication. So you're going to multiply your number, and then there is no other X to multiply by, and then you're going to multiply your Y's. And remember, when you're multiplying, you add exponents. If there's no exponent there, put it there. You know that every number and every variable does have an exponent. Now, the opposite of finding the product or multiplying is finding the quotient or dividing. So same thing, you keep your base, but instead of adding your exponents, you're going to subtract your exponents. And remember, if you have a negative base, keep parentheses, right? Keep it in parentheses. If you have a negative base. So for example, if you have a negative 4, keep it in parentheses before you put the power up there. Okay. All right, number 9 says write using a negative exponent other than 1. Okay, and that's fine because the exponent's not a 1 anyway. So remember, if you want to force a negative to change the sign, you change, I'll go back in just a second, okay? To change the sign, you change the location. So if it is currently in the bottom and you need to make it a negative, then you just change the location. So if you've got 1 3/9, all right, you're going to move it up to the top, and then you're going to apply that negative. Okay, move it up and then apply the negative. So remember, if you want to make yourself a note here, If you're going to change the sign, you change the location. And that's if you're going positive to negative or negative to positive. Either way, you change the location. All right, number 10 wants you to evaluate if B equals 5. Okay, if B equals 5, can you do that after I'm done for a sec? Thanks. If B equals 5, please. Then in the place of B, you're going to put the 5, and then you're going to evaluate it. And remember to deal with negative exponents. Okay. And then for number 11, remember that you have to write the A down here and then show your bounces and then write your final answer with the decimal point written in the proper location. Okay. All right. So that's what I'm going to give you here as far as hints and notes. I will scroll back up and leave it on the screen, Robert, if you just tell me which one you want. And then you've got today to work to finish the one from Thursday, do the one for today. They're both due tomorrow, and we will take chapter 9's test tomorrow. Okay. If you're at home, email me with any questions.